Chakravarti from the global webinar series. Today we have Dr. Kiran Manjappa from National Institute of Technology, Karnataka, Surathkal with us. He's going to take a topic on blockchain, revolution or evolution. Dr. Kiran received his BE Information Science and Engineering and MTech Networking and Internet Engineering under Vishwashraya Technological University from JNN College of Engineering. He received his doctoral degree in 2014 from Department of Information Technology, National Institute of Technology, Karnataka, Surathkal, Mangalore. He is awarded with Rajiv Gandhi National Scholarship for pursuing his doctoral research. Currently, he is working in NIT Surathkal as assistant professor in the Department of Information Technology. He is having 14 years of teaching and research experience. He has contributed to literature through many international conferences and journal publications under IEEE, IET, and Springer publishers. He has published a research-oriented textbook named Quality of Service Aware Routing Protocol under leading publisher CSE Press, Tyler and Francis Group in 2016. He is writing another book called Advances in Deep Learning for Medical Image Analysis, a Practical Approach, which is about to be published in 2021 by Tyler and Francis Group. He is Technical Expert Committee member for the Smart City projects called E-Library and Centralized Command Center in two districts, Shimoga and Mangalore of Karnataka, India. He is also the Technical Committee member of Regional Academic Center for Space, sponsored by ISRO in NIT, Karnataka. His research interests includes blockchain technology, 5G and beyond, soft computing and swarm intelligence. So we are happy with you, sir. So we want a wonderful session from you. Dr. Kiran? Dr. Kiran Manjappa, good morning. Welcome to the global webinar series.
Very good morning. Whether my voice is audible?
Audible, sir.
So actually, Chakravarti sir, yeah, I am trying to share my screen.
Yeah, you can share it now. So you are showing me.
Yeah, 1 minute. Whether my screen is
yes, 1 minute.
Yeah. 1 minute. You can see my screen, right?
Yes, Kiran, you are audible and we can see your screen, full screen.
Whether my voice is clear?
Clear.
Loud and clear, sir.
Okay. Okay, so thank you very much. Thanks for the nice introduction. My name is Dr. Kiran. I'm from NITK Surathkal, Karnataka. And so welcome to webinar. And so my topic is blockchain technology. And I'm going to tell you whether it's an evolution or revolution. And so I would like to clarify one thing here. So I'm not, dealing with, or I'm not giving any information on Bitcoin technology. So I'm giving information on technology behind Bitcoin, that is blockchain technology. And to start with, so contents goes like this. The very first content what I'm going to discuss is the blockchain. So what do you mean by blockchain? So how chain is maintained, and so basically the what is what kind of thing. So next I'm going to tell you how chain is maintained. So in blockchain, so working of blockchain, and followed by blockchain architecture. So we got architecture for blockchain, so which is quite flexible. So we can tune up the architecture for any application. And so we can go for, next I'm going to discuss blockchain applications, followed by blockchain research challenges and question and answers. So here I'm not most frequently asked questions I myself have put in the PPTs, and I'll show you that. So because whenever I go for blockchain presentation, the most frequently accessed questions I've noted down, and so those probably those questions will be having in your mind. So probably you'll be hesitant to ask those things. So I'm helping you out. So I'll put those questions myself in my slides. So coming to my very first topic, blockchain, blockchain, blockchain. So blockchain, what do you mean by blockchain? There are different versions of definitions. So if you take any textbook, there are, according to their comfortability, they have given the definition. In a vague way, what I can say is blockchain is a chain of blocks. So just like a nodes in the linked list. So you're very much familiar with linked list. I don't need to stress much about that linked list. So in a linked list, there'll be numerous nodes, and each nodes are, all the nodes are connected using the reference. That's a memory reference. So just like that, here also we got numerous blocks, hundreds of thousands of blocks, and those blocks are linked through reference, memory reference. So, and it looks like a chain. It looks like a chain, so that's why it is called as chain of blocks. It's a very kids version of definition blockchain. And so the next thing is it became extremely popular because of its distinguishing features. And what are its distinguishing features? The very first one is it's an open ledger. And so we call it as ledger because so whatever you write, so it's open to, I mean, it's a what kind of storage kind of thing. So it looks like a ledger, which is open. So open in the sense anybody can see this. Anybody can see the content of blocks in the blockchain. So that is why it is called as open ledger. So this is one of the distinguishing feature of blockchain. So next thing what we got is the distributedness. So this is distributed. The blockchain is built on distributed network. So that means it avoids the central servers. So because it avoids central servers, so this is democratic. So that means users will drive the blockchain network. So there is no concept like server which holds all the nodes and all. So users, they got complete freedom. So they can express their their feelings. They can do if a miner or if you feel like it is wrong, you can directly say that it is wrong in the blockchain network. Whereas this is not possible in server client server architecture. So where whatever decision has to be taken, server has to take it. And am I whether my voice is clear?
Yes, sir. Clear and loud.
Okay, thank you very much. So there is no central server, hence it is democratic, and so it's going to cut out the middleman. So middleman in the sense, for example, so if I want to transfer money to you, for example, and so mediator is the bank, and we have to stick on to the rules and regulations of bank. So there are a lot of these steps, and there are a lot of hiccups will be there. So not a lot of, but minimum hiccups will be there. And we should stick on to the rules and regulations of bank. That is that hinders the process. So even if you go for online process, online left and all, so there are some rules and regulations that we should stick on to. And so that is a tedious job for the users. So that middleman, so we have removed in blockchain technology. And so a single chain contains all information. So a single chain, suppose if I say banking sector, so we are maintaining only one chain across banks, complete sector, complete banking sector. We got only one chain which contains all information. So you can imagine so how much big that chain would be and how much enormous information that chain would contain. And next thing is so one more feature of blockchain technology is user anonymity. And so here, so if I log in, so nobody will come to know, so what is my background, what is my name and how I look like and all. So it's completely anonymous. So that is one more feature of blockchain technology. So coming to revolution or evolution. So if you think that blockchain is a very recent technology, I'm very sorry. So cryptocurrencies were, it's a very decade, not a decade, it's a multiple decades old concept. It was introduced in 1980s itself. And so very first cryptocurrencies was introduced by David Chan. and in 1984, so he introduced blind signatures as well as secret sharing. So that kick-started the blockchain, the technology. And next we got eCash. So we got from CFN authors, and so followed by eCash, again eCash by brand. So this eCash from CFN as well as eCash from brand is a optimization of cryptocurrencies introduced by David Chong. So in 1984, and then we got Hashcash, so which was introduced by Adam Baek in 1997. And this Hashcash, let me tell you, it revolutionized the mailing industry, mailing sector itself, email sector. So this using this hash cache, so the system will identify whether a mail is spam or what. Accordingly, it will put that mail in the spam folder. And how it's going to find out? So based on the amount of the processing time you have used to create that mail, and that information unknown without your knowledge will be put into your mail. And when I may receive that mail, so it's going to check whether so how much memory, or how much processing time so you have used to develop, create that mail. Accordingly, accordingly it will be bifurcated as genuine mail as well as spam mail. So this hash cache is followed by so one cryptocurrency called as B money in 1998 by VD. And so it is just like creating e-money cryptocurrency just like Bitcoin by solving computational puzzle. And it is a very first P2P application what we can see. So just before blockchain technology. And so each and every node contains a transaction, just like blockchain technology what we have now, today's blockchain. And so it is a bit closer to blockchain technology what we have. Uh, and next we got Bitgold in 2005, and it was introduced by Nick Szabo. So disadvantage of all these things, so all these technologies what we have seen so far till 2005. So was like it was a P2P application. So because it was P2P application, distributed network, so nodes, so they used to disagree. So because of disagreement, so transaction used to take much time to get accepted in the network. So there was some disagreement between the nodes, and that is called as consensus. Consensus means agreement among the nodes. So that agreement among the nodes was not there. So consensus algorithm was missing in all these technologies. And further, so added to that, so we had one more disadvantage, that is a central third party. A central third party used to maintain all these things. So if you take Bitcoin, B-Money, Hashcash, or eCash, or anything, so there was some central third party. So it was controlled by that central third party. That distributedness, decentralized distributedness concept was not there in the previous technology. So and after that, so next came Bitcoin. So very famously, known by anyone and everyone, and it was introduced by Satoshi Nakamoto, a pseudonym. So in 2008, and what he did was, so he introduced, he avoided or he overcome that loopholes what we found in the previous technologies. He added consensus algorithms, and he has used Hashcash as a proof of work for the consensus algorithm. So these two changes he added, and he called it as Bitcoin. So you just see this one. So here we got Bitcoin, B money. So then we got Bitcoins. So always it starts with either B or B gold, Bitcoin, or B money, something like that. And so in 2009, practical implementation of Bitcoin came into picture to the real world. So Bitcoin 2008 is a white paper basically, so introduced by or written by Satoshi Nakamoto. And in 2009, so practical implementation came into picture. So very first block of Bitcoin was mined in 2009. So that's what we mean to say. If I say practical implementation, the chain started in 2009. So Bitcoin chain. So this is so all about the history of blockchain. So it is not a revolution. It evolved slowly right from 1980s. So slowly it got optimized by itself. It started with eCash in 1980s. Slowly it moved to from centralized to distributed network, B2B network, and there was a server. Then that server concept has been removed in Bitcoin technology, and the consensus algorithm has been used by Bitcoin technology to to resolve the ambiguity among the nodes, and Hashcash was used to check out how much effort has been put by nodes. So just to prove yourself, that I'm not a hacker, I'm not a I'm a legitimate user. And in 2009, practical implementation came into picture. So now, so Satoshi Nakamoto, so it's a pseudonym. So nobody knows who is Satoshi Nakamoto. But there was some research. So these researchers, they will be finding for some reasons or some field to do some research. So nobody was knowing who is Satoshi Nakamoto, and some researchers researched on this one. So they started search that they did all those literature survey and all, and they said that this uh, Nick Szabo, the very previous version of Bitcoin, so that is Bitcoin introduced by Nick Szabo. So he is the Satoshi Nakamoto, and Nick Szabo said that no, I'm not Satoshi Nakamoto, and so he gave hundreds of reasons, so telling that I'm not a Satoshi Nakamoto and all. But still, so till now, so people don't know who is Satoshi Nakamoto, but there is always a gossip on the Nick Szabo. So why? Because why they said that Nick Szabo is Satoshi Nakamoto means. So he introduced consensus algorithm a little bit. The idea of consensus algorithm in Bitcoin or Bitgold. Okay, so for that reason, people doubt that Nick Szabo is Satoshi Nakamoto, but actually nobody knows who is Satoshi Nakamoto is. So this is about the evolution of blockchain technology. So I'm not discussing. I didn't told anything about blockchain technology, but I told the application of all these. I told the applications which uses blockchain technology. So invariably, we are talking about blockchain technology here. So though we are talking about applications like Bitcoin, BGold, BMoney, and all those things, eCash and all those things. So behind the screen, so they are using blockchain technology only. So that is evolution. Okay, that's the evolution of blockchain technology. So always it's a big debate. So somebody says that it's a revolution. It's revolutionized the industry. So Bitcoin from 2009, almost all companies are moving towards blockchain. It completely revolutionized. It came up and it revolutionized. But actually, it's an evolution. If you ask me, it's an evolution. It's not a revolution. It is an evolution. So that's about history of blockchain. So coming to differences between centralized and blockchain model. So centralized model goes like this. If I say centralized model, I'm referring client server architecture. So we got a single central repository, that means in server. So it got a single point of failure and single point of attack as well. And if you go for centralized model, so we got may not publicly available. The data is available in the server. There are hundreds of restrictions. You might have to go for 100 steps to access those information stored in the server, and modification can be done at any point of time by the administration, so without the user's knowledge. So that is important within code, without the user's knowledge. So any administration can take any decision, and accordingly it can modify anything in the server. And so it required trusted third party to maintain servers, because maintaining server is it's a cost consumed process. Like we have to pay much to maintain their servers. It's a hi-fi systems. Not to do that, so companies or the applications used to outsource that thing to the third party. And every time, so registration is required with the new policies. So every now and then, so policies used to change. So for that policies, we need to register. So accordingly, we have to, so that we can access the information. So that was a drawback of this client-server architecture. So for that reason, people moved to the blockchain model. So that's a new model what we have. So copy of the chain will be there in each and every node. So that is why it is distributed. It is not a centralized server. So the centralized server concept has been removed in each and every node. The participating node, that node, so the information will be there, repository will be there. And so it is publicly available. As I said, it's an open ledger. So it is publicly available to anyone and everyone can see the content of blocks. And so once entry is made in the chain with timestamp, you cannot change it, you cannot modify it, you cannot delete it, you cannot do any alteration to that information. So that is a feature of blockchain, one of the feature of blockchain model, blockchain technology. So where once information is stored, that's it, you cannot modify. Whereas if you go here, just see this one, third point in client-server architecture. So modification can be done at any point of time by the administration, so without the user's knowledge. So that's a contradictory statement what we got in new model. So whereas once entry is made, so we cannot change the content of information in the block. So that is the advantage what we have. So that means we cannot, always we can take out the truth from the blockchain model. So what happened exactly? So that information we can get it. And so no need of trusted third party. So because each and every chain so contains that information, and each and every node contains, and each and every node contains that chain, and these nodes will drive that network. So for that reason, trusted third party is not required. And the centralized server is not there. For that also, trusted third party is not at all required to maintain that centralized server. And communication between customer and service product. Okay, so that's a third party is not required for this one. And chains are stored in local repository for all the miners. It's the same thing. So here, if I say node, that is nothing but miners. So invariably, I'm referring these two things. If I refer node, so there I'm referring miners. If I refer miners, I'm referring node. So invariably. And if chain is corrupted, always a miner can get back the fresh chain, so with its speed. So because it is distributed. If I say distributed, each and every miner is connected to each and every other miner with a single hop. I'll explain all these things in the coming slide. Just so for timing, just remember that if any node's chain gets corrupted, so because of hardware failure or software failure or anything, always that miner or always that node can get back the fresh chain. So using by contacting its peer. So this is the advantage of new model, blockchain model, what we have compared to the centralized model. And because of all these reasons, all of a sudden, so not all of a sudden, like when Bitcoin introduced probably like 1 6 ago, so it added much weightage to that technology. And so slowly, all the companies are moving towards this blockchain model. So as I said, so blockchain contains blocks, and each block looks like this, just like nodes in the linked list. There are two parts in each and every block. One is header part, another one is transactions part. So this is block N, and similarly like this, we'll be having multiple blocks. You can see this one. So block N plus 1, block N plus 2, and each blocks are linked or through reference. So just like linked list what we have, so that is why it looks like a chain of blocks. That's why it is called as blockchain. And the very first node in blockchain is called as a genesis block. In this example, this is the genesis block. So just like we refer very first node in the linked list as header node or first node, something like that, or convenient way. So just like that. So here we got a genesis block. That should be the very first block in the blockchain, and followed by that genesis block. So hundreds or thousands of blocks will be there. So this is how your blockchain looks like. So hundreds of blocks will be there like this, and each and every block so is referred to the previous block. So if you take this one, so this is the latest block what we have. So this block has got a reference to the previous block, and if you take this block, so this block has got a reference to previous block. So like this, a chain is maintained. So let us see how this chain is maintained in the coming slide. So just see this. So as I said, so header and transactions part will be there in each and every block. The header information contains multiple information depending on the application what you're developing. So that's how I put this, extra etc. here, the multiple dots. But apart from that, there are some default fields which each and every block should contain. So irrespective of application. So irrespective of whatever the application you're using, so blockchain solution you're given to application. So these three fields are mandatory. So first one is Merkle root, second thing is previous block hash, and third thing is timestamp. So this Merkle root I'll explain. So just keep it pending. So previous block hash, you know that. So because to maintain the reference, you know how to maintain the chain. So this previous block hash is also called as hash pointer. So you know the pointer word, so pointer variable, so which gives the reference to, which gives the memory reference. So here we got hash pointer. A hash pointer is one, so which uses previous block hash plus reference. Hash plus pointer. So that's why it is called as hash pointer. So hash is a previous block hash. A pointer is a reference to previous block. So combining those two things, it is called as hash pointer. So this hash will give the genuinity of the block, and the reference will give where exactly that that block is stored. So we are using hash pointer to maintain the link. So now, so timestamp gives at what date and time so this block has been created. So these informations will be stored in header. Remember, so once you store this information, you cannot change it. At what time, who has done transaction, those information will be stored here in this header part. So coming to this Merkle part, so and before that, so this so how this previous block hash is maintained, we just see this. So we got latest block and we got the previous block here, and the header part, the previous block header part we are hashing, and that hash information we are storing in this previous block hash part of the next header. And of course, the reference will be added up here. So I'm not sure this one here, the reference part. So like this, the link is maintained. So coming to transactions part, so each and every block contains multiple transactions. And how much transactions it contains, it depends on the application. So for example, if I take Bitcoin, so each and every block size is 1 MB. And there are variants of Bitcoin where the block size has been varied. And so here, so in this example, we just see this one. I'm using Merkle root, not AMP. So the technology. So this is the best way what we can store the transactions in the transaction part of the each and every block. There are multiple ways to store the transactions. You can store it serially, or you can store it one by one, like a stack. But the best way is this Merkle tree representation. This is called as Merkle tree representation. And let us see how this Merkle tree representation looks like. So for example, here we got the 4 transaction A, transaction B, C, and D. And this is the leaf node what we have. So as I said, it's a Merkle tree. These are the leaf nodes. It's a bottom-up construction of tree. I just say this. So transaction A, a hash of transaction A plus hash of transaction B will form hash of AB, and that will be parent node of these transaction A as well as transaction B node. And similarly, you just say this one, transaction C and transaction D. We are taking hash of these 2 transactions and we are constructing one node and we are calling it as hash of CD, H of CD. So now say this, so 2 level has been constructed. So we will go up. So now say this, H of ABCD. So this H of ABCD, hash of ABCD is constructed. So by taking hash of this node and this node, hash of CD. So like this, we will go on constructing the nodes till we get root node. So from the leaf nodes, we will start from leaf node to the root node. And this hash, so hash of ABCD, the root node is called as Merkle root. And that is stored in the header part of each and every block. So now see this one, if I refer this Merkle root, it is referring, so one of the transaction here. Okay, so from this transaction, I'm constructing this Merkle root, and this Merkle root will be stored in header part. So now if I access this header, I'll come to know, so what's a Merkle root? And if I get this Merkle root, I can get any transaction. The transaction A, transaction B, transaction C, or transaction D. So one more advantage of this Merkle tree representation of transactions is the searching is very easy. You just see this, if you want to get transaction A, just start from root node. So every time you're reducing the searching area by 50%. So here, so if you start from root, So you're going to, the left subtree, so where you're discarding all the right subtree. So here again, you're reaching the left subtree again. So in this example, straight away I'm reaching the transaction A, but it is not like as easy as that, like this in the, the real world. There'll be hundreds or thousands of transactions. If I say 1 MB, the size of the block, if I say the size of the block is 1 MB, you can imagine how many transactions you can put. So here we are not putting like, if I say, okay, I'll come to that. So like this it goes. So one more thing I would like to highlight here. So here I've shown that even number of transactions are required to get to root node to construct the tree. So there are some cases where a node or miner will be waiting for transactions, where we have only odd number of transactions and it is waiting for one more transaction to make it even, so that it can construct the Merkle tree. But it waits for a longer period of time, but transaction did not come, but still it is waiting. In such cases, what miner can do is, miner or node, it can create a dummy transaction it can add it at the end, and it can make it all, the even number of transactions. It need not to wait for actual transactions happening in the network. So it can create its own transaction, a dummy transaction, just to create a tree. Okay, so that is supposed to be the last transaction in the leaf node, or the last node in the at the leaf level. So these transactions are stored in the transaction part of the block. The header part contains all this information. The Merkle root is a root node of the Merkle tree. The Merkle tree contains the transaction. So it's at bottom of construction. So we will start with the leaf nodes. Then we will go on constructing the parent node of each and every leaf node. So like this it goes. So now say this, what could possibly go wrong? So for example, you got a transaction here. So you got a block here, and a block contains transaction. And some intruder changes the content of this transaction A. So if I say hash of this transaction A, so we are using cryptographic hash function, for example, SHA-256, that is secured hash algorithm, and why it is 256? Because it gives 256-bit hash value. And so in this hash functions, cryptographic hash functions, they are so sensitive. Even if you change 0 to 1 or 1 to 0, if you change any bit, the hash will change. So now see this. So for example, so in this transaction here, so instead of sending 100 bitcoins, or instead of sending 100 rupees, sending 100 rupees, an intruder has added one more zero there. So that means instead of 100, now we got 1000. So because of addition of that zero has changed the hash here now. So this hash will change, and correspondingly this hash will change, and correspondingly the Merkle root will change. So it's a series of effect what we have. If you change one transaction, a series of uh, uh, a series of effect will happen there. So that is why it is very difficult to change one transaction and to keep it unknown. So you need, if you want to change this one, you need to change this, and if you want to keep the secret here, if you want to then you need to change this one, and that is not enough. You have to change here as well, and that's a very tedious job. So here we got only the 3 level. We just imagine if you got thousands of transactions in one block, or for example, say 100 transactions in one level. You can imagine how many levels would have been there, and how much intruder, how much you need to struggle to change the content of each and every parent node. So that is the advantage of blockchain what we have. If you want to change any transaction, you have to change concurrently all the parent transactions in order to keep this secret within the transactions. And that is the advantage what we have. And so that's what. If Merkle root changes, hash will change. So hence with the previous block hash. So if you change the Merkle root, so we are changing the header. You just see this one. So here, see this one. So we are taking hash of the header of previous block. And if you change the Merkle root, so here, the Merkle root of this block, the hash will change. If you change the hash, so hash pointer will change and the reference will change. So that is the what do you call the secret what we are maintaining here. That's a technique what we are maintaining here to maintain the link across the block. If we change any transaction, the reference will fail and hash will fail. Accordingly, reference will fail. Then one can easily come to know something is wrong with the transactions present in the block. And so that is about how header part and how the header part is stored and how transactions are stored. And says a Merkle root is a very well proven technology what we have to store the transactions in the block. So now coming to blockchain architecture, so we have an internet here. So down the line we have, and it has been blocked by this dialog box. So behind that we got our internet, and above that internet we are constructing this distributed network. So this distributed network you can see, so it's a heterogeneous one. I mean to say, we got a desktop here, we got a mobile here, we got a laptop here. So any PDS can participate in this distributed network. So distributed network in the sense you can see that. So this mobile node, this miner, I should say, this miner or node, I can say. What do you mean by miner? I'll tell you that. So this is a miner, so which drives this network. So all these things are miners. All these things are miners. So these miners will maintain this distributed network, and we got a different color combination here for different miners. So that means we got different types of miners. A miner can be full miner node or a pruned miner node, or it can be SPVs in the sense simplified payment verification node. So full node is one which holds complete blockchain, and the prone node is one which holds part of the blockchain, and SPVs are those. So you can see this. These are all SPVs. These are all SPVs where it won't hold the complete blockchain, but it verifies the transaction. So it will give a little contribution to the network. Okay. So that's how these systems these miners are interconnected through this distributed network. And within this distributed network, we got two concepts here. So one is smart contract as well as the consensus algorithm. A smart contract is one, so which is a business logic. So for example, if you are giving a blockchain solution for financial transactions or financial sector, say for example. So what smart contract should contain means, so suppose financial transactions means I should give my credentials, and I should have enough balance in my account, and the other person have to prove his credentials and all those things. So basically how the transaction has to be done. So basically if and else conditions. Okay, so that thing is called as smart contract. That's a business logic. So it's an application logic what we have. And we got a consensus algorithm. So consensus means it's an agreement. So because you can see that, so here we don't have any centralized server. So we don't have any centralized thing at all. So all those things are, all those miners are interconnected. So they drive this blockchain, they drive this distributed network, P2P network. And so this consensus algorithm holds these miners in confidence. So consensus is basically agreement. So because here we don't have any centralized server, so always these miners, so because there is no centralized authority, so these miner can behave whatever like in whatever they want, like. So it should not be there. So because if I behave in a different way, so then if all other miners are behaving in one way and I behave in a different way, so probably it might affect the distributed network. So for that reason, so we are so through consensus algorithms, so we are giving an agreement among the miners. It's an agreement among the miners telling that I won't deviate from the protocol. So I'll agree to these rules and regulations. I'll agree if transaction is right, I should agree with that one. If transaction is wrong, I should say transaction is wrong. So there's an ethics what we are putting in consensus algorithm. So this consensus algorithm drives all these miners and keeps all these miners within this boundary. So these are the two logics what we have in blockchain technology: smart contract as well as consensus algorithm. Smart contract is basically business logic. We don't have any research part here, but most of the research is done in consensus algorithm. So I'll tell you much about that one. And this distributed network maintains this blockchain. You can see that. And most of the blockchain, you can see we call it as dApps, and it is at the user level. And this distributed application so uses blockchain information. Okay, so we can access the information stored in blockchain using this distributed application. So these distributed applications are used by users. There are two types of players in blockchain technology. So first one is miner, another one is user. So user sits in user level, user layer. That is, you can access blockchain through blockchain distributed application, dApps. Whereas miners comes in second layer of blockchain architecture. So just like OSI layer architecture, so here also you've got a layers. You can say this. So this is the first layer what we have. So this is second layer, and this is the third layer what we have. So we call it as first layer research, second layer research, and third layer research. So here research is not much there. So just a developing application like how best we can access the blockchain information. But here most of the research is happening here only. So especially in consensus algorithm, like how best we can reach out the other miner. Just see this one. So this miner, if it wants to reach some other miner here, so these three miners. So what could be the delays? How to reduce that delay, and how security has to be given. So if I want to send some information within this network, so how security has to be maintained, so that integrity and all those things. So that is, that's a research what going on, the recent trend. So it's a block, I mean, layer one research and layer two research. So here what research is going on is, so what could be the best size of the block, and how this header information is stored, how the transactions are stored in this transaction part of each and every block. So that research is going on. For example, so Merkle tree is one research, so where it says that, so this is the best way of storing all the transaction. So where, so it gives a security as well as, so searching a particular transaction is very easy. So if you go for tree-like representation, that is one research what people have done. So like that, you can do multiple research in layer two as well as layer one. So consensus algorithm as well as distributed networks, that is another research area what we have in blockchain architecture or blockchain networks, blockchain technology. And so coming to working principle of blockchain, so here, so user initiates transactions. So just I would like to mention one point here. So here users will sit here and miners will sit in the first layer of the blockchain architecture. So miners can be users as well. Sometimes so miners can be users. That means so users can initiate transactions. Okay, users can initiate transactions. So miners can be users, but users cannot become miners. So miners can play a dual role there. So that's what. So user initiates transaction. So here, so initiating transaction means, for example, say, so there are two stores, so which accepts bitcoins. Suppose I want to purchase one item from their shop, and I want to pay through bitcoins. So that means I should get connected to the Bitcoin network. So software what Bitcoin provides, and I should give those bitcoins, or I should transact those bitcoins to the shop owner. So that is called as initiating transaction. That means sending a bitcoin. Okay, sending. I'm putting myself in the Bitcoin architecture or Bitcoin boundary, so that because everybody knows Bitcoin, so that's why I'm using this Bitcoin. So if I want to send Bitcoin from my account to another account, that is one transaction. So that is, I'm a user. So I'm initiating that transactions. Once I initiate that transaction, so that transaction is given to the nearest miner. So nearest miners or nodes. So once the transaction is received by the miners, so he has to check the transactions, validate. I mean, he should check the transaction for its credibility. So that means validating transaction. So here validating means there are different checklists, like I should sign using my private keys, and I should have enough bitcoins in my wallet, and the public key and all those things. Different checklists are there, and these miners will check all those checklists against this transaction. If a transaction is not meeting any of those, any even one of that checklist, then it will be discarded as it is, then and there itself. So or else it will go for next level. So where nodes will aggregate all those transactions into candidate block. A candidate block is one which is not yet added to the main chain. So because it is still under construction, so where we are adding transaction to that block, it's the newest block in the blockchain. So this is called as candidate block. So under construction, what I can say, so block which is under construction is called as candidate block, which is not yet added to the main chain. So once the miners aggregates all those transactions, verified and validated transaction into the candidate block, so that block has to be broadcasted to each other. So why each other? So that means supposing that I'm a miner, I'll create a candidate block, and the candidate block what I have created, so I'll disseminate that candidate block to all other miners, and all other miners have to accept it. So that's what it says. So that's a consensus what we have in blockchain technology. Just see this. So next we got a consensus phase. So the candidate block what I have created, for example, I'm a miner. So some user has initiated transaction. I've included that in the candidate block, and I'll fill up candidate block according to the size of block, and then I'll disseminate all the candidate block to the network, where all other miners have to come to one agreement, have to reach consensus. So what consensus they should reach? So they will see the candidate block transactions. They will check that those transactions are already mined transaction, mining in the sense already those transactions have been processed or what, and so whether the transaction is not whether it satisfies all those conditions or what, and whether the block structure is proper or what, and whether the header part is properly mentioned or what. There are many checklists there. So this checklist is different. So where transaction validation is there, and this checklist is entirely different. During consensus, the checklist is against the block. So here the checklist is against the transaction. So each and every block will go through this consensus, and so each and every miner should accept it. So suppose I've created a candidate block, I'll give to you. You will check all those things, whether the transactions are right or not, whether the Merkle root is right or not, whether the header part is maintained right or not. You will check all those things. At last, you will say yes. So if everything is in the proper place, then you will say yes. So like that, all the miners have to accept it. If majority of the miners accept this candidate block, then this candidate block will be added to the main chain. So how this candidate block is added to the main chain? Remember, so each and every miner maintains a chain, local chain. So based on how many miner accepts it. If it is a majority, then I'm going to add that candidate block to my chain. Similarly, you will add that candidate block to your chain. So like this, each and every miner, based on the majority of acceptance, so that candidate block will be added to their own chain. So that is a local change, which which drives the global change. I'll add that candidate block to my chain. You will add that candidate block to your chain, and similarly some other miner will add that candidate block to its chain. So based on the consensus. So like this, the local change will drive the global change. So this consensus phase, if consensus is reached, candidate block is added to main chain. So this is the working principle of blockchain what we have. Okay. So next, so miners, so functionality of miners. So first you need to join the network and listen for transactions. So whenever the user submits the transaction, you need to validate those transactions. You need to construct a candidate block and listen for new blocks and validate and rebroadcast a new block whenever it is proposed. So here the role of miners is it should listen to the transaction as well as it should participate in the consensus algorithm as well. Consensus means when a new block comes, it should validate all those things. So always preference is given to the new blocks. So that means supposing that you're validating transactions and immediately a new block came. So then you will, complete that validating transaction. Then you will take up this new block. You will validate that block against the checklist what I said just minutes before. So that's a functionality of miner, and it stores and broadcasts a blockchain to the pairs. So it stores a local blockchain, a local repository, as well as it broadcasts. So why it should broadcast? If there is a if something goes wrong with the network, then it will broadcast its blockchain to the all other miners. So it is not actually broadcast, it's a worst case. So actually it's a unicasting. So unicasting your blockchain to the other peers. So if that peer is running out of some problem. And so that is the functionality of miners. So miners are backbone of blockchain technology. So miners drives blockchain networks. So miners maintains blockchain. It's a miner's responsibility to check or to maintain the credibility of the blockchain. That means the information stored in the each and every block. So it's a miners. It's all about miners. So coming to advantages of blockchain, so maintains trust between the parties. So because I sign each and every transaction with my private key. So if you see any transaction, signed by the private key, you'll come to know that. So it's a legitimate transaction. So you have to maintain the private key privately. So if you lose the private key, that's a different story. Okay, and transparency is guaranteed. So here, as I said, so open ledger, so anybody can see what is going on in the blockchain using distributed ledger, distributed apps, D apps we say, and then immutability, data cannot be changed or erased. As I said, if you change it, then the Merkle root will change. It's a chain reaction. If you change the transaction, the parent node will change. Parent node, it goes on, it reaches up to root node, and the Merkle root changes, and Merkle root header changes. If header changes, the previous block hash will change, and it's decentralized. So because we are using P2P network, distributed network, and automation. So as I said, so miners will take care of all those things, and a smart contract, it will drive the business logic in the uh, distributed network. So there is no centralized authority there. So it reduces human power basically. The disadvantage of blockchain is scalability. So there are three types of blockchain basically. So public blockchain, private blockchain, as well as consortium blockchain. And public blockchain and private blockchain, the name itself explains the things. If you go for consortium blockchain, it's a combination of public as well as private, half public as well as half private. And so scalability problem comes in mainly public blockchain. If I say public blockchain, so any miners can join the public blockchain. Even me, you, as a with the desktop, you can join the blockchain network as a miner. So it's very difficult to control. So when there is no, it's when it is open-ended, number of miners joining the blockchain or number of miners joining the networks, it goes on exponentially. If such is the case, the robustness will be bit less, because whatever the algorithm you take, if number of users are varying drastically, the robustness, naturally, so the performance will degrade. And so there'll be huge data in the chain over a period of time. As I said, a single chain contains all the information. So for example, if you take Bitcoin and Ethereum, so which started in 2009 and 2015, so right now we got 269 GB of Bitcoin blockchain, and we got Ethereum 140 GB. So why this, it's almost decade old, but still we got 269 GB in a sense. Initially, that awareness was not there, and compared to today's awareness, so when it was in 2009, it is a bit less actually. So nowadays, people are moving towards Bitcoin, so that's why slowly it is getting, boomed up by around 2025, 2025. So probably it will be doubled. And if it goes on like this, from somewhere down the line, there will be huge amount of data in the blockchain. And so maintaining that data, maintaining that blockchain chain of blocks, so probably will be a headache for the miners. So right now it is okay, 269 GB, 140 GB, it's okay. But so as the days goes on, so probably it will be hiccup for the miner. So for that reason, what people have done is, it's slightly contradictory to the statement what I gave just minutes back in the previous slide. So deleting the old data. So though it is immutable, so they are trying to delete the old data. So if I say deleting, they are actually not deleting the content. They are moving that old data to the side chain. So that means they are having two chains. One is main chain, and you are maintaining another chain, side chain, which contains old data. So just like a storeroom, what we have in all the departments. So for example, see this one. So suppose you are developing a financial transaction, you're giving a blockchain solution for financial transactions, say. So now, so I've transacted somewhere in 2009. So now it is 2020. So what I have transacted in 2009, it's of no use to me. So why to maintain such information in blockchain? It's of no use to me at all. So I need information. So just 2 years back information. That's it. That information is more than enough for me. Or for example, 5 years information. So 2000 decade old transaction I don't need at all. So such information I can go for side chains. So you can put all those information in side chain so that we are giving some relaxation to the miner. So if it really need that information, then it can refer side chains. It is not, it's not required basically. So it's an ongoing research. All those people, all those delegates, so who have the research thing, so research thing in your mind. So you can work on these side chains as well as how to maintain data in the blockchain efficiently. So this is one of the things. And coming to blockchain application, we got supply chain management, healthcare, property inheritance, food safety, real estate, data sharing, so passport verification. The list goes on. So for supply chain management, you can say that like right from the first checkpoint to the last checkpoint. So you can track it. So where exactly the product is, each and every checkpoint will store one information in the blockchain. So that means, so from one checkpoint to the another checkpoint, if something is missing, so always you'll come to know. So what had happened in the previous block, previous checkpoint. And healthcare information that I got a separate slide for it. I'll let you know that. So property inheritance means basically I'm talking about land registration, and so real estate is also a land registration thing, and food safety is basically so right from farm to plate. So what exactly, how it exactly travels your food. So that information also you can get it from blockchain. So already some research has been done, and some info. I mean, I think in US, I guess. So they have done a blockchain solution for food safety. They can check out. So in a market, in a supermarket. So if you take any product, so you can see, on what date it was packed, and when it got shipped, and from when it was purchased from the farmer, and all those information can be seen. And data sharing, so of course, so whatever you want to share the data, you can put it in blockchain, and the other users can see that. So that's the advantage of data sharing. The passport verification is very, very important. You can avoid the duplicate passports. So once you put a passport information in the blockchain, suppose I got one passport in my blockchain, I cannot get the another passport because already one information is there referring to my Aadhaar card and all those things. Already it is there in the blockchain. I cannot get another passport. So that verification can be done. So blockchain applications, the list goes on basically. So coming to this, the recent developments, so you should be happy like Google is moving to blockchain. So it is giving a cryptocurrencies, I guess. Yeah, yes, it is giving a cryptocurrencies basically. And so whereas apart from cryptocurrencies, Volkswagen is using blockchain for supply chain, and Samsung is also moving for blockchain for supply chain as well. Okay, so there are many applications. There are many business tycoons, so who are moving to blockchain. So I'm coming to question and answers. So there are here I'm putting most frequently accessed questions. So very first question, what people will ask is, can blockchain be used as we do online banking? Yes, you can use it, but the problem is anonymity. So anonymity hides the users. So some countries may not like this. For example, so India itself, India doesn't like this. So whatever I do, whatever the transaction I do, the banking in the banking sector, so it should be visible to RBI. So whereas if you go for blockchain, so anonymity completely hides my identity. So that is why this Bitcoin and all, it has been banned in the India. So you can buy Bitcoin, but you cannot convert Bitcoin to fiat currencies. Fiat currencies in the sense the currencies. So the Indian currencies, Indian rupees that you cannot convert. So you can buy Bitcoins, but you cannot convert that Bitcoin to Indian rupees. That is banned. And so usually what happens is because of this anonymity, hackers hacks the website and they will ask for ransom through Bitcoins only because you will not come to know who is the other end. So only thing what you can see is the address, Bitcoin address, wallet address. That's it. The Bitcoin address is that's it. So Bitcoin behind the Bitcoin address, who is there and where he is sitting, so what he is doing, whereabouts, his whereabouts you cannot get at all. So that is the advantage of blockchain as well as disadvantage of blockchain as well. So that is why. So if you go for online banking, uh, probably like some countries may not like it. And the next question what we have is, can I become minor? Yes, of course, you can become minor. Anybody can become minor. So provided it should be a public blockchain. So supposing that if you want to become a miner for Bitcoin, so you can download the supporting software and if the with a sophisticated hardware, you can directly become a miner. So there is no issue at all. Anybody can become a miner. Me, you, your neighbor, and anyone can become a miner. So provided if you go for private blockchain, so you need to authenticate yourself. So that means the private organization, they got their own they may not allow you as a unknown person. So they want a known person. For example, if I give a blockchain solution for JNTUV, for example, say, and you won't allow me because I'm an outsider there. You allow you allow only your miners like your own in a boundary. So that is the thing what we have. So if it is a private, so chances are less. And if it is a public blockchain, always you can become a miner. And so what are the requirements to become miner? It depends on the blockchain networks. For example, if it's a private blockchain, so there is no much requirement. So with a little bit higher configuration system, that is enough for mining the blocks. And a dedicated and sophisticated system should do. And if you go for Bitcoins, don't ever think to become miner because already big tycoons are there mining the Bitcoins. So probably like just me competing with Usain Bolt. Of course, Usain Bolt will win because there are different already established different tycoons are there who are mining that Bitcoins. And so coming to next question, for every transaction, blockchain has to update the hash for validation. So how efficient is the process with respect to time and memory? So these questions with respect to consensus algorithm, especially with respect to proof of work. So there is one consensus algorithm called as proof of work, which uses hash cache. So where you should prove yourself, like how much time I have used to process the transaction or to create that solve the puzzle, something like that. So here, so creating hash. So you might think that it's a tedious job, but it is not as tedious as you think. Because for that we got a dedicated hardware called as ESIC, application specific interface card or chip, you can say. And this job of this ESIC is to generate hash. That's it. So you got a dedicated system, so which uses ASIC, and job of that system is to generate only hashes. That's it. And so it can generate tera hashes per second. The latest one is it will generate 13 tera hashes per second, and you can imagine that's a very huge, very huge amount, and it should be dedicated miner. That means you're not supposed to do any other thing in that system. So now see this one. So I'm giving a picture here. So where a miner is mining the blockchain blocks transaction by sipping a coffee and having some good time. If you think like that, the miner job is not as easy as it is shown in the picture. You can see this. So these are all miners. So here is an ASIC application specific interface card. So can you see these racks? The rack full of ASICs have been put here. Maintaining these racks, and and one ASIC will give 13 terahash, and you can see this um, how much ASICs have been deployed here, and how much hash will be generated. So this is regarding Bitcoins I'm talking about. So that's why I said, if you want to become miner for Bitcoin, just drop your idea. So you cannot buy all these things. It is, of course, you can, depending on your interest, but you cannot compete with these people. So the thousands of AICCs have been racked together here. So it is very difficult to compete with such a well-established environment. Okay. And the next question what we have is, how can I make blockchain as my career? So right now, choosing blockchain as a career is a you need to hold on, like, because right now blockchain slowly all the companies are moving towards blockchain, but it is not well established yet, because once the blockchain is settled, there will not be any maintenance at all, no human intervention, and there will be it works by its own, like all the miners will take care of those things. Only thing what you can become is miner. That's it. And of course not for bitcoins, because already well established miners are there, and it's still under research. You have to wait for some time. So you can go for dApps. So you can develop distributed applications, and you can ask your organization to develop a blockchain solution. So with that dApps, so you can give access to different users, and so like that. So giving a blockchain solution for the private organization is comparatively it is easy. Okay, so comparatively it is bit easy. So that you can do. So the complete based on the block structure. So how you are maintaining that link between the blocks, how transactions are maintained. So based on all those things, you can develop a very small application. And so what are the steps to become masters in this field, in this blockchain field? My suggestion is read, go on reading textbooks. There are hundreds of textbooks. So I won't prefer anyone, because my it's very subjective if I say any textbook based on your comfortability, based on your based on based on different parameters, you can choose any textbooks available in the Google, and so you should get your hands dirty with the codes. So reading not only with the theoretical knowledge, you cannot become expert. You should work on. You should develop blockchain. There are many development tools. For example, we got Ethereum. Ethereum client is there. Ethereum client RPC. So using that, you can develop your own private blockchain. You can develop smart contract using Solidity language. Solidity is an open source tool. You can download that, and you can develop a smart contract for different applications. And you can develop consensus algorithm using Go language, Golang. And so you can see that if you Google that GitHub, so there are many consensus algorithm available. There are many smart contracts available using which you can use that. You can deploy that smart contract in Ethereum. You can inject your own consensus algorithm in the Ethereum. There are many test networks. You're not using actual miners of Ethereum. There are some test networks, so which tests your research, your new inventions. So you can go for that. So the best option is Ethereum. Ethereum client RPC is there. You can go for that. And apart from that, you can develop your own setup, local setup. You can go for 3 to 4 systems. You can make 3 to 4 miners. You can set up a P2P network then and there itself, and you can work on that. Is also possible. So people are working on it. And so how blockchain can be used to store medical records, and how useful it is in drug industry. And so we can have a single ID for the patients across the hospitals. So it's a very ongoing, happening research field in blockchain technology. So how blockchain can be used to store the medical records. So here what exactly happens is, So if you go for one hospital, so they will give one ID for you. That means they will create one record and they'll store that in their private repository. And for some reasons, if you go for another hospital, and again there also they'll create one more repository, and they'll create one more entry of you and your history, and they'll store in their repository, and it goes on like that. And somewhere down the line, if you go to some other hospital, he cannot access the previous hospital's records. That's the problem what we are facing now, right now. So because most of the time patients will not be remembering, for some reason they'll not be remembering. So what diagnosis previous doctor has done, and what medications previous doctor has prescribed, and all those things. So for some reason they'll forget that, and again the same procedure has to be repeated again and again. So that should not be the case. So for that reason, what we can do is we can give a blockchain solution for healthcare record. So across the hospitals, we are maintaining only one blockchain. For example, if you go to any hospital, ID is created. So that ID is a unique ID, and your entry will be there in the blockchain. Supposing that I'll go for hospital XYZ, and in that hospital XYZ, one information, one entry is there with my ID. So next you'll go to another hospital for some reasons, and there if you give your ID, the doctor can extract so your history and your prescription, and so some more information. So from that blockchain, that is the beauty of this blockchain with the when you go for medical record storage and all. And this is one part of the story. The other part of the story is it is very helpful for the research. So because if you go for research, so getting data set is very difficult. So still we are working on the old data set only. So where so we'll take up that data set, we will slightly tilt it, we'll create some more images, we'll work on it. So the results will change if I change the content, or if I tilt it and all those things. Suppose here, for example, you just see this one. So while adding your, so for example, so I'm a patient, I'm giving, so hospital is creating my record, say for example. So while creating a record, the hospital will ask, so whether I'm ready to share these prescriptions, so these MRIs or these X-rays to the researchers. If I say yes, so directly researcher can access that blockchain technology, blockchain, not technology, blockchain network, and they can use the MRIs or prescriptions of me. So no need to go for any data set and all those things. All the data are available in the blockchain itself. So you just imagine so how much useful such a blockchain is for the researchers. They don't need to go anything, anywhere. So if you access that blockchain, whoever the patient has given permission, they can download that information, they can work on. So that is a added advantage of blockchain technology for the medical records. And that's all from my side. Hope I made justice to the one hour 15 minutes what professor has given to me. So this is my email ID, Kiran Manjappa at nitk.edu.in. So Kiran Manjappa at gmail.com. And if you have any comments or if you have any doubts, you always can contact me. And I do thank so JNTUK, Professor Chakraborty sir, so for giving this opportunity. So especially in this pandemic situation, so we should keep ourselves engaged. So this was one of the situation where I kept engaged by giving this lecture. So thank you very much. Over to you, please.
So thank you, Dr. Kiran. Thank you very much for your wonderful session. It was like a slow and smooth and very interesting with all your examples. We are happy to you.
Yeah.
Any questions from participants? They are keeping in the chat box. Shall I read you for you this one?
1 minute. Chat box. I cannot see. Proof of work and proof of stake. So there's a question from Amardeep, Mr. Amardeep. State difference between proof of work and proof of stake. Proof of work and proof of stake. Proof of work is basically used in Bitcoin and proof of stake. Not exactly proof of stake. Delegated proof of stake is used in Ethereum. And proof of work is basically it all about hardware, like how sophisticated hardware you have. So the hardware, what do you call? If you have a sophisticated hardware, definitely you're going to win. If you go for proof of stake, as the name itself indicates, it's a stake. I'm putting some stake there. Um, so like if I put more stake, definitely I'm going to win. So there in proof of work, it is hardware matters, and in proof of stake, stake matters here. So that's a one difference what I can tell. Of course, there are many more differences. So main difference what I told.
There is another question actually before that. Consensus algorithm used in distributed system, linked concepts with Chinese, Merkle tree structure used in MD6, peer-to-peer communication needs timestamps. Hash code is from hash function. So shall I conclude the idea of blockchain is distributed system plus hash function of MD6 plus linked list plus peer communication with timestamps?
No, linked list is not there. Please, you have to remove linked list.
Yeah. So that was from Dr. Syed Saul Hamid.
Any more questions? I would be happy, please.
So can blockchain application be applied in computing marks in an educational institution?
Yeah, definitely. Not computing marks. We can store the marks cards so that the user, students anywhere, even if he goes to US, he can access it. So you can create a private blockchain.
Marks, that's it.
That's not possible. Computing marks.
Will the solidity and go long ways are sufficient to deploy blockchain?
No, you need consensus algorithm. Solidity. Okay, can you repeat the question, please?
Will the solidity and /R go long ways are sufficient to deploy blockchain?
A complete blockchain solidity language, that should be enough. Solidity is basically used to write smart contracts, and Golang is for writing consensus algorithm. You need to deploy these two things in a test networks. For that, you need Ethereum client RPC. Ethereum client RPC is required. That's must and should. Or you can go for Hyperledger as well, but these tools changes. But I'm comfortable with Ethereum. That's what my team is working on.
Somebody asking what is enterprise blockchain?
Enterprise blockchain is one which is, for example, Samsung only. I showed one example. Samsung is moving to blockchain technology for supply chain management. So it's an enterprise blockchain actually. So which is not basically cryptocurrency based. That's it. So
is there any cases of hacking of blockchain?
Yes, there are some cases. So it all depends on the smart contract, how you write business logic, I say. If you won't write business logic properly, so if there are some loopholes, if there are some bugs, definitely intruders, they will encash it. There are some cases. Recently, in last year, I guess, China-based cryptocurrency, they stopped it completely. So because somebody hacked it and he transferred all the money to his account. That's what.
So what kind of research we can do in consensus
algorithm?
Yeah.
So basically, in consensus algorithm, how exactly you're one example is Byzantine problem. Byzantine fault tolerance, we say. So because there will be multiple miners, and each and every miner have to adhere to consensus algorithm, but they won't adhere because of many reasons. They will behave in their own way. They will try to put some other wrong transactions and all. How to avoid such things we need to think of. So if you ask me, you just write a consensus algorithm for private blockchain. So don't go for public blockchain because maintenance is very, very difficult. Write a consensus algorithm for private blockchains. So private blockchain means number of miners are restricted. So you have some liberty there. So that is what. If number of miners are restricted, you can take decisions. If n is not restricted, taking decision is very difficult. You can go for a private blockchain and target the Byzantine fault tolerance. And so one more thing is like there's a researcher called as Itai Abraham. Itai Abraham. Okay, so just Google his the pages. He has written very nicely about Byzantine things. Itai Abraham is an author. He's a well-known author. He's a VMware scientist.
Amadip is asking, name some popular platforms for developing blockchain applications.
Ethereum client RPC is the best one. So most research has been done in Ethereum client RPC only. And here and there, Hyperledger is used. I won't prefer Hyperledger because it won't give much liberty to you to work on. But Ethereum client RPC is the best one. So you got a lot of options there.
How to prevent from intruders while doing transactions?
How to prevent?
This is a generic question, actually.
Very generic question. Diplomatically, I can say that you should be safe. That's it. Be safe. Don't share your private password. And if something goes wrong, immediately you just change the
M. Narasimhalu Garu, we will be covering this topic in the next sessions by CDAC and certain people. So they are giving, they are going to enlighten on all these things, intrusion detection and all this. Okay. So thank you, Dr. Kiran. Thank you very much for your session and Q&A. Suddenly we had some question. Shall we go for it?
Yeah, please. Yeah, please. Now I will be happy to.
Yeah, mining algorithms, traceability, chain algorithms can be applied to what blockchains, either public or private consortium?
In any kind of blockchain. It is applied to either public, private, or consortium. Anything.
Will two similar transactions have the same hash? If yes, there can be repudiation attack, right, sir?
No, not at all possible, even in my dreams.
So that's it.
Because the hash is 0 to 2 to the power of 257. The number would be 0 to 2 to the power of 257. It's a quite huge number. So getting a same hash for two different transactions, it is not at all possible. Not at all possible. So just imagine 0 to 2 to the power of 257. 2 to the power of 257. Just imagine how big it is, like the range I'm talking about. Somebody is asking. Asking mail ID.
I'll share the PPT. I'll share the PPT. Anyhow, in the PPT, your mail ID is there. They can take it down. Okay.
Yes, Professor.
Thank you very much.
Thank you. Yeah, thank you very much. It was my pleasure. So it was a very smooth presentation. Even I felt as well. I'm happy. I don't know about the participants, delegates, but I'm happy. Thank you.
Also very happy. We are happy. Thank you very much.
If any other opportunities are, just let me know. So I'll be happy.
Yeah. So see, this is like a buffet where we are just giving 1 hour session on each topic. So later we want to have elaborate session on each and every topic.
Yeah, that because within 1 hour I cannot say much. So just it's an eye opener.
Yeah.
Just an eye opener for you people. You should go and you should go on reading this. So if you have feedback,
we'll have more collaborations.
Yeah, please. I would be happy to. If you have taken feedback, you just please share it with me, Professor.
Thank you very much.
So, okay then.
Thank you all. Thank you all for participating. I'm closing the session.